6 years ago, I bought a 3,300-watt grid-tied inverter from SoFar. At the time, it cost around $400. It has operated reliably for 6 years without any issues. During that period, I gradually increased the capacity of my solar panels and added battery storage so it could operate at night. However, the current 3 kilowatt capacity of this system no longer meets my needs. In particular, the recent surge in oil prices has caused the cost of cooking gas and fuel for vehicles to double. I've switched to an electric vehicle and electric cooking. What I urgently need now is to upgrade my solar power system to a higher capacity. I chose a 6 kilowatt hybrid inverter from the Synergy brand. The price of this unit is around $500. The reason it has become so affordable recently is that many brands have entered the hybrid inverter market. They compete aggressively on price, which makes it much easier for us to own a hybrid inverter at such a reasonable cost. Inside the box, you get a user manual along with CO/CQ certification documents, basically proof that the unit has passed factory testing before shipping out. Synergy also includes all the essential cables, from parallel connection cables for multiple inverters to battery connection leads. One notable component is the clamp-type current sensor. This little device plays a crucial role. It allows the inverter to monitor power flow and ensures that excess energy isn't fed back into the grid, but instead stays within your home to power your loads. And of course, you also get the full mounting kit, including screws and a wall bracket, so you can get everything installed right out of the box. At the bottom of the inverter, you'll find all the connection ports, including inputs for the solar panels, battery connections, communication ports, a backup output, a generator input, and the main grid connection. All of these ports are sealed with rubber gaskets to protect against dust and water, meeting an IP65 rating. That means the inverter can be safely installed both indoors and outdoors without worrying about environmental conditions. On the side, there's a power switch for turning the unit on and off. You'll also notice the cooling fins, which are used to dissipate heat from key components like the inductors and transformer. On the right-hand side, there's a specification label showing the inverter's rated operating parameters. Thanks to its wide operating range, this unit is highly versatile and can easily integrate with most solar power systems, whether old or newly installed. Around the back, you can get a clearer look at the inverter's cooling system. The IGBTs, which generate a significant amount of heat during operation, are actively cooled using forced air from built-in fans to ensure stable and reliable performance. Here's a look inside the inverter. A large ribbon cable connects the display to the main board. You can also see the oversized battery terminals, designed to handle currents of hundreds of amps. Next to them are 12 capacitors from Jamacon, Taiwan, each rated at 2,200 microfarads and 63 volts, forming part of the power filtering stage. This small yellow transformer is part of the auxiliary power supply. It steps down the battery voltage into stable rails like 12 volts, 5 volts, and other required levels to power the inverter's internal control modules. This inverter features 2 independent MPPT inputs, which means you can connect 2 separate solar arrays with different panel counts or orientations without worrying about reduced energy harvesting efficiency. It uses a boost-type MPPT topology, where the voltage from the solar panels is stepped up to around 400 volts. This is achieved through IGBTs and boost inductors, which are tightly potted and mounted onto a large aluminum heatsink at the back for effective thermal management. A cooling fan is used to circulate air inside the inverter, creating airflow to carry heat away from components like the capacitors and other internal parts. This warm air transfers heat to the inverter's enclosure, which then gradually dissipates it into the surrounding environment. Right here under my hand are the IGBTs and diodes for the two MPPT modules. With just two IGBTs and two diodes, this inverter is capable of handling up to 9 kilowatts of PV input power. Pretty impressive. To save space, the power filtering stage and relay block are moved to the upper section. These relays are responsible for connecting the inverter to the grid during grid-tied operation, as well as switching 220 volts from the H-bridge to the backup output. Each relay is rated at 32 amperes, ensuring it can handle the required load reliably. Next to it is the main brain of the inverter, the DSP controller. It is responsible for controlling all the major sections, including the MPPT, the DC-DC stage, the synchronous rectification stage, the H-bridge, as well as other subsystems. You can also see the IGBTs mounted onto a large aluminum heatsink using ceramic insulating pads. These are definitely more reliable than the typical silicone-based insulation pads. I won't be taking it apart any further. If I do, chances are I'll end up with a few extra screws when putting it back together. If I ever get the chance to repair a similar hybrid inverter, I'll fully tear it down and give you a much more detailed look inside. I've fully installed it into my system. As you can see, it's running in grid-tied mode with load limiting, and I'm only drawing a few watts from the grid. The large touchscreen is a great addition, very responsive and easy to use. You can quickly adjust settings and monitor all the key parameters. It also runs very quietly. The cooling fan at the bottom rarely kicks in, so you can install it indoors without worrying about noise. Since I installed it myself for personal use, the setup isn't exactly the cleanest. Wiring's a bit messy. When I have some free time, I'll tidy everything up and make it more organized. I also added a small electrical cabinet to house the necessary breakers. There are two MCBs for the two PV strings and a transfer switch that allows the house to switch over to the backup output in case of a grid outage. There are also a few additional MCBs for different household circuits. In addition, I'm using two CT current sensors for the grid-tied load limiting function and another CT for the external power meter outside the cabinet.